Okay, so I have another question here. It says, this comes from the lesson, word problem involving calculations from a normal distribution. Okay, so here's the question, sample question. Batteries from a certain manufacturer have a mean, so that's important, the mean lifetime of 860 hours with a standard deviation of 90 hours. Assuming that the lifetimes are normally distributed, complete the following statements. So before we begin, I want to go ahead and write that down. The mean, and we're going to use the Greek letter mu, is the value 860 hours, and then the standard deviation is 90 hours. It's important to go ahead and label that because that's going to be important. So it's approximately 60%, I'm sorry, 68% of the batteries will have a lifetime between blank and blank hours. Okay. What this is, this part A, relates to what's called the empirical rule or empirical probability, rule, something like that. What that means is, let's draw something first. So let's draw our normal distribution, if you will. So we'll try to do the bell-shaped curve. Please forgive me if I don't do it perfect. Okay, the mean is always at the middle, the mean. Okay, in the standard normal table, we assign that to be the value of 0, but we'll get there in a second. The mean is always in the middle. When you count, what you do is you go 1 unit over. This unit over is 1 standard deviation to the right. Okay, so this would be mu plus 1 standard deviation. When we're in the when we're dealing with normal distribution, we like to count our units, our standard deviations. So we'll go over here, and this will be 2 standard deviations, another one. And then we go over here and we count 3 standard deviations. We can go the other way too. We can go over here, and this is 1 standard deviation. We say it negative, but it's 1 standard deviation to the left. The negative means left. But the distance is still 1 standard deviation. Or we could go 2 standard deviations right here. So we say -2, but what that means is it's -2, it's 2 standard deviations to the left, and so on. And then we have also, then you can go 3 standard deviations to the left, negative. Okay, so what's the purpose, and how does this relate to the empirical probability? Well, there's some rules, there's some sort of guidelines. It says 68% of the data will be within 1 standard deviation of the mean. 95% of the data will be within 2 standard deviations. So I'll do this, standard deviations. And 99.5%, 99.5 or 97.5? I think it's 99.5 of the data will be within 3 standard deviations. What does that mean? Let's go back over to our drawing here. What that means is that if you go over here to the go over here to the 1 standard deviation mark, this one, and go over here to the left one. Go left and right. So it says within 1 standard deviation to the left or to the right. So what we're going to do is we're going to put a box right here between the 1. And what we're saying is that within this box, 68% of the data will exist. 68% of all your data will lie within 1 standard deviation to the right of the mean, 1 standard deviation to the left of the mean. That's 68% of the data lies in that box. That's what this means right here. Okay, and then the second rule says, well, let's widen our box. Let's put our box at 2 standard deviations to the left and right of the mean. And so in this box, if you will lie 95% of the data. That's what the empirical rule says, is that if you put the window 1 standard deviation on both sides or 2 standard deviations on both sides of the mean, that's how much data you're going to capture. So then, now let's take a look at this problem. Now let's take a look at this problem. We are told the mean here is 860. We know we want 68% of the data, so that means we want 1 standard deviation to the left and 1 standard deviation to the right. So 1 standard deviation to the right is found by adding the standard deviation. Oh, well, the standard deviation is 90. So so this value right here is 860 plus 90, which is what, 950. And then this value right here is 860 minus 90, minus 1 standard deviation. So that gives us what, 770? So the values are 770 and then 950. And it all stems from the empirical rule of probability. We wanted 68%, so it's connecting it to 1 standard deviation left and right of the mean. And so you just take your mean of 860, add 90, and then subtract 90, and you get your endpoints. Okay, so that's the first part of the problem. Next part of the problem, let's erase all this and start over. So let me draw my normal distribution again. And I'm going to try to draw, please don't judge me on my drawing abilities. It's usually pretty terrible. Okay, so again, the mean is here at 860. Okay, so what they want to know is what percent of the data lies between 590 hours and 230 hours. So 590 is over here, and then 1130 is over here. We'll do a quick calculation here. I'm curious about something. Okay, that's what I thought. Okay, so what we're going to do here, there's going to be sort of 2 ways we go about doing this. What we're going to do is we're going to find the z-scores associated with the values of 590. What's the z-score associated with this? And what's the z-score associated with this? And what you have to use is the z-score formula. The z-score is equal to the value you want to find the z-score of, minus mu, the mean, divided by standard deviation. X minus mu divided by the standard deviation. So when we do for 590, the z-score is this, 590 minus the mean, which is 860, divided by 90 for the standard deviation. When you do that calculation, you should get the value of -3. Okay, we'll do the other one. So we'll do 1130 minus 860 over 90. And this one is going to give you a +3. Uh-oh, look at that. I'm surprised. I'm excited, but here's why I'm excited. Remember I told you what this does. What does this 3 connect to, by the way? Hold on. If we were to translate this to the standard normal table, the mean corresponds to a z-value of 0. This -3 value here means that this 590 corresponds to a z-value of -3. And over here, this corresponds to a z-value of +3. Now, what the z-values mean is how many standard deviations away from the mean are you? This says I am 3 standard deviations to the left of the mean, and this says I am 3 standard deviations to the right of the mean. That's what the z-value actually means, is how far away from the center are you? How many standard deviations away from the center? How many standard deviations to the left or to the right? Okay, now the cool thing is remember I talked about the empirical probability. I said the empirical probability tells you 68% is within one standard deviation of the mean, 95% is within two standard deviations of the mean, and then I think three standard deviations, and that's what this is: three standard deviations to the left, three standard deviations to the right. I think that's 97.5% the data is, or no, it's 99.5. I'll look it up right quick. I'll figure it out. So hold on just a moment. Okay, I just confirmed it. It's not 99.5, it's 99.7% of the data. Okay, so approximately 99 because this is three standard deviations between the mean by way of the empirical probability, then we know it's 99% of the data is in between these two lifetime values. That's what the empirical probability is all about, the empirical rule. Okay, hope you found this helpful.